All right, so now we're going to look at the inverse of a function, and we find the inverse of a function when I reverse the x and y coordinates of every ordered pair. So either I could start with a table of values or a list of points and just reverse the x's and y's. So my inverse, so I'm going to call it only f inverse if my inverse is actually a function. For right now, I'm just going to list it as inverse of f. So I'm going to take all my points and reverse them. So I'll get 2, 1, 0, 2, 3, negative 3, 2, 4, negative 2, negative 1, and 2, 0. Since I have 2, 0, 2, 4, and 2, 1, my inverse is not a function. So I can see that straight away. So I could answer down here, no. I could also see that if I graph it. So I'm going to take my original points and I'm going to graph them in this green. So 1, 2, and then let's go ahead and plot its inverse simultaneously. I'm going to put the inverse in purple, 2, 1. So there they are across from each other. And then I'll have 2, 0, and 0, 2. So again, here we are across from each other. And then we've got negative 3, 3. Reversing them, I'll have 3, negative 3. Again, we're across from each other. 4, 2, 3, 4, 2, and then 1, 2, 2, 3, 4. Again, still across from each other. Negative 1, negative 2. And of course, that will correspond to negative 2, negative 1, still across. 0, 2. I have already. So now that's also a green one, which means this one will also be a purple one. So here's my row where I can see the failure of the vertical line test for my inverse, because I have 3 purple values that for the same x have 3 different y values. I also want to plot the line y equals x. Excuse me. So when I put in this line y equals x, what I can see from this is that here's my line y equals x, and it seems to follow my reflection. So here were my points reflecting across, always reflecting across y equals x, and sure enough, that's one of the properties of the inverse function. So the graph of the inverse is the reflection on the line y equals x.